if you're a manager of a business, you're responsible for engineering how you do that business. There are not fixed ways of doing business. There may be regulations, there may be rules, there may be customer demands, but you have to design how you want to do business. You're not stuck in the same rut that you have had in the past. To make continuous improvement and to beat the competition, you have to re-engineer your business. And you got to assume that as part of your strategy. Now I'll harken back to the job I got after the fab shop, and I was asked to run an electronics factory in Flemington, New Jersey. This factory, they had fired the previous two general managers because they were not producing, and so I got the task. The environment was, we were building terminals. About as complex as PCs, but they were fixed function terminals that hooked up to mainframes. This is the early 80s now, so we didn't have PCs yet. And these terminals, we co-designed the terminals with Hitachi. They did some design, we did some design. They did manufacturing, we did some manufacturing. And the concept of the environment was that whoever had the best quality and the lowest cost would get 60% of the production. And those who were inferior got 40% of the production. But the reality of the situation was that if that gap between the two facilities was big enough, then the one that was doing the best would get all the production, the other guy would disappear. So we were at the low end of that, we were at the bottom of that. We had to find a way to leapfrog over the Japanese, the Hitachi, to have higher quality, lower cost. Now, back in the early 80s, every American manufacturer was hopping on airplanes and flying over to Japan to learn about Kanban, zero defects, and all that, all the Deming work and so forth. And you could barely even get a flight to get over to Japan and back. But my thought, and we did that too, but my thought was, holy cow, if I learn from them, that's good, I learned something. But I'm never going to be better than them. How am I going to have my facility be the dominant in this relationship? So I figured we had to think outside the box. Because our chairman, a couple of years earlier, the chairman of the company, this is Burroughs Corporation, the chairman of the company had decided to hire A.D. Little to do an assessment of our manufacturing. $2 million, and about 6 months later, they came up and said, we're pretty good. And they couldn't come up with any real recommendation to do better. Well, the chairman got mad, threw that out, hired Goose Allen to do the same thing, $2 million later, and 6 months later, they came to the same conclusion. My conclusion was, okay, we're the best, but we're not good enough. So something has to change. We had the best industrial engineers, we had the best design. We got to find a way to take a leapfrog up. So we had to get, in our strategy, we had to come up with different ideas. Now, where are you going to get different ideas? You can't ask the same people you've been talking to help you come up with new ideas for your strategy. So we decided to go outside of the box and hire people that were not traditional in our industry. The first area that I concentrated on, I happened to be in Hong Kong, and I was visiting the Wang brothers, and they manufactured in Hong Kong, but mostly in the New Territories, but they're stationed in Hong Kong. And they made Donkey Kong toys, the Donkey Kong video toy, and the Nintendo sets. And they made thousands a day of those sets. So I was marveling. These were not, they seemed like toys, but they were fairly sophisticated. They had microprocessors in them, they had electronics in them, and their arrival quality was 100%. Because if you're manufacturing toys and people start buying the toys and 1% don't work, you lose your reputation. No parent's going to buy that toy for their kids because it just creates frustration. So they had figured out how to get 100% perfect quality in their arrivals. So I poached a couple of engineers. I went in there and hired a couple of guys, brought them to the States and said, you're part of my advanced team. I need to know what you're thinking. Donkey Kong's a toy, it's not a sophisticated computer, but they had ideas that were different than what our guys were thinking of. Next, down the road about 5 miles with a company called Continental Can, and they manufactured cans. Now, what can I learn from Continental Can when I'm building electronics? And what I saw was, when they were producing cans, various different sizes, various different materials, various different opening mechanisms, various different labels, and they were all coming out the end of the line without any type of real manual intervention. So they were somehow putting plans in, and out the end of the line, without reset up, they were producing cans. So I'm sitting there saying, wow, there's something that they understand. Now, I know it's not electronics, but there's something in the way they're doing their business that allows them to efficiently be very flexible. And that hit a chord with me, because while the Japanese at the time were very good at manufacturing, they required fixed schedules for 90 days. You had a schedule for 90 days, you could not change that schedule. And as a result, they produced configurations of products that were fixed 90 days in advance, and if you forecasted wrong, you held inventory. And so it was a very expensive process. They built great, perfect products, they're high quality, but they built what they wanted to build for that 90 days, and you couldn't change it. So they lacked flexibility. Continental Can, on the other hand, had flexibility, so I wanted their thinking. So I poached an engineer out of Continental Can. Then we figured I needed some additional brain power. I went to MIT and hired a couple engineers right out of MIT with masters that had in information technology that I felt I needed to put into this mix of thought. And then I took the best engineers, because after all, A.D. Little and Booz Allen said our guys are the best, so I took some of our best engineers, put them into an advanced team to come up with a new way of manufacturing electronics. And we came up with a process called BTCO, Build to Customer Order. And the concept was that everything we built was a unique item. It had a serial number. And every part, major part that went in there that was variable, like disk drives, memory, size of memory, the type of microprocessor, all were configurable. And each one of those pieces has an individual identity. So that when an order came in for one of our products, a single unit, now they may have ordered hundreds at a time, but each one had a single identity. And when that order went into the system, we identified exactly what piece was going to go into that product, regardless of whether the piece was in inventory or on its way from Intel or on its way from the disk drive manufacturer. We identified that item specifically. And if the schedule changed, it would ripple through and those identities would be changed out. As a result of all this, our fortunes changed. They changed. Our factory went from a $70 million factory to $770 million. Our inventory went from $50 million, which was horrible when you had a $70 million shipment, went to $20 million, which was very good turn. Our obsolescence went from $15 million a year down to zero, because we had control of all our inventory, and most of it was still in the hands of our suppliers. We didn't own it. In fact, we had negative inventory because we paid our vendors after the customers paid us. So we had a negative inventory, which meant we never owned anything that wasn't already in use. So we had zero obsolescence. Back originally when I got to the factory, we had 1,000 employees, and they were working 6.5 days a week. I mean, ridiculous hours. And they obviously were failing because they were tired. No time off, we were just beating everybody. When we got to the 770 million, we had the same, not the same, but we still had 1,000 people only select overtime, which was mostly in engineering when we had some projects that had to go through some equipment that had limited capacity, so we would work overtime. So we were enormously successful. Hitachi was shut down from producing the product, and we got to 100% of the production. That was like in 2 years from the time we started.